Let's find theta in the diagram below. There's a very tall, narrow building, 200 meters high here. The lesser building is 110, and the two buildings are 180 meters apart. And the question is, as you're viewing this epic taller building, can you determine using math the actual angle? And the answer is yes, we can. By cleverly dividing this big angle into two parts. We'll call this angle A, and we'll call this angle B. And this is both right triangles. And let's focus on the top triangle. The entire height is 200, and the lesser height is 110. So that means that this is the leftover, 200 minus 110, which is 90 meters high here. And now we can figure it out. Let's draw the triangle over here. So this is 90, this is A, and the question is, can we figure out this angle given this bottom part here is 180? Opposite adjacent. We'll say tan of A is equals to the opposite, 90 over 180. If you really want, you can reduce it. If dividing top and bottom by 90, we have 1/2. So therefore, we find the angle A by taking the tan inverse of both sides. So tan inverse of 1/2. Using your calculator, we have approximately 26.6 degrees. And now we repeat the same process for the bottom triangle. So we copy the bottom triangle. We have 110. We slide this 110 over here, which becomes this number 110 over here. And 180 slides up as well. And we're interested in angle B. Using SOH CAH TOA, we have opposite and adjacent. So SOH CAH TOA, we use tan of the angle B is equals to the opposite over the adjacent. We find the angle by taking the trig inverse, which would be tan inverse of 110 over 180, which is approximately 31.4 degrees. As we add it with the previous result, we get approximately theta is equals to 58.0 degrees, combining A and B. Let's move on to a 3D pyramid problem. The height of the pyramid below is 6 meters perhaps, and the base here is 4, and we have a square base. Find theta. So if this entire bottom is 4, the halfway point would be 2. So I'm going to copy down 2 here, and we're going to focus on this right triangle here. So let me just copy to the side. We copy the inner part here, and we can see this is a SOH CAH TOA triangle. We have opposite and adjacent. SOH CAH TOA, opposite adjacent, we'll use tan. Tan theta is equals to opposite over adjacent, and we find theta as the trig inverse of this number, which is 3. So tan inverse of 6 over 2, or 3. And with a calculator, we get 71.6 degrees. Now let's focus on solving alpha in this right triangle here. Notice how we have a nice smaller square, which is 2 by 2. This is 2, this is 2. And using the Pythagorean theorem, we can find the hypotenuse, which would be c. So we'll just say c squared is equals to 2 squared plus 2 squared. So therefore, c squared is equals to 8. Taking the square root of both sides, we have c is equals to root 8, or 2 root 2. So we now redraw this inner triangle. Over here, it is a right triangle, even though the perspective might show otherwise. And we're interested in this angle, alpha. And we have the information opposite over adjacent. So we use tan. Tan alpha is equals to opposite over adjacent. So if you really want to simplify, 6 divided by 2 is 3. So we could say 3 over root 2. So alpha is equals to tan inverse of this number, which is approximately, with a calculator, 64.8 degrees.